Hey everyone, and welcome to RUBIN'S MindLab, where we break down the latest research into what it really means. Ever wonder if the advice you get from scientific studies actually makes sense, or if it is just a fancy way of saying something we already figured out? Well, today we're diving into whether the language scientists use might be pulling the wool over our eyes. Especially when it comes to applying research in the real world, we're going to explore a fascinating study that looked at how scientists talk about their findings, specifically whether they accidentally imply that one thing causes another, even when their study design might not really prove it. Imagine this: you are reading a scientific paper, and it sounds super convincing. It talks about how one thing leads to another, and then it gives you advice on what to do. But what if the study itself wasn't really designed to prove that one thing causes the other? That is the core puzzle this research tackles. You've probably heard correlation does not imply causation. It is a mantra for any student of science. It means that just because two things happen together, like ice cream sales and crime rates both going up in the summer, it doesn't mean one causes the other. There is usually a third factor, like warm weather, that influences both. True cause. And effect usually needs experiments where you can manipulate one thing and see if it changes another while controlling everything else. But here is the kicker. Lots of research, especially in fields like psychology that deal with people, can't always be done with strict experiments. Sometimes researchers use observational studies where they just observe what is happening without changing anything. The problem, as this new study points out, is that even when they're not supposed to claim causation, the way they talk about their findings, and especially the advice they give, can strongly sound like they're proving cause and effect. This study is actually building on previous work that found this exact issue in health research. It looked at how scientists linked exposures and outcomes, and how they made recommendations. They found a mismatch. So the researchers here wanted to see if the same thing happens in the world of business and workplace psychology, an area called industrial organizational or IO psychology. This field is super practical, often giving advice to companies. So the risk of misleading recommendations is high. They picked a hot topic in this field, psychological capital or PsyCap. PsyCap is basically a combination of 4 feel-good, can-do qualities: hope, self-efficacy, believing in your abilities, resilience, bouncing back from setbacks, and optimism. Think of it as your inner superpower toolkit for life and work. The goal of this study was to be like a detective. They wanted to investigate 50 research papers about PsyCap and see how the language used could imply causality, especially in 2 key places. First, in the sentences that connect the things being studied, and second, in the advice or recommendations the researchers give at the end. To do this, they searched for articles about psychological capital. They then carefully read through 50 of these papers. For each paper, they looked at the main sentences that describe the relationship between different variables. They specifically focused on identifying the linking words like related to, associated with, impacts, or influences. Then, they judged how much these linking words implied that one thing caused another. They used a scale from no implication to strong implication. Think of associated with as a low-level implication and enhances or improves as a stronger implication of causality. For example, a sentence like PsyCap was positively associated with ASP and PSP might have no causal implication, but a sentence like both salespersons, self-monitoring and PsyCap enhanced sales performance has a much stronger, more causal sounding implication. They also looked at the recommendation section of each paper. If the researchers said something like companies should invest in PsyCap training for employees, they asked themselves, does this recommendation require the assumption that PsyCap causes some positive outcome? And how strong is that implied causality? They used a similar scale for these recommendations, from no implication to strong implication. To make sure their judgments weren't just personal opinions, they had a separate person, an independent rater, go through and do the same thing. They then compared their ratings to make sure they were on the same page. This is really important for making sure the results are reliable. Now, for the juicy results, what did they find? Well, it turns out the issues they saw in health research are definitely present in PsyCap research too. The researchers found that a lot of the linking language in the abstracts, the short summaries of the papers, already implied a pretty strong level of causality. About 48% of them were rated as having a strong causal implication, even though these were observational studies. And in the discussion sections, where scientists often interpret their findings, the situation was similar, with a substantial portion implying strong causality. But here is where it gets really interesting. When they looked at the action recommendations, the advice about what to do, the results were even more striking. A whopping 85% of the recommendations found in the abstracts were rated as having a strong causal implication. And in the longer discussion sections, 84% of recommendations also had strong causal implications. recommendations. This means the advice given could basically only make sense if you assume that PsyCap causes certain outcomes. Think about a recommendation like this one. Any investment in PsyCap training programs could represent a winning and sustainable HR strategy aimed at improving the potential of individuals and teams and at increasing the competitive advantage of the organizations. This sounds like a command, a clear directive that implies training PsyCap will directly lead to better company performance. Now, here is the big contradiction. Despite all this causal-sounding language and advice, very few studies, only about 10%, explicitly stated that their goal was to figure out cause and effect relationships. Even more surprisingly, almost half of the articles, 42%, actually included a warning, a disclaimer saying that you shouldn't draw causal conclusions from their findings, because their data was, for example, cross-sectional, meaning it was collected at just one point in time and can't show what came first. This is where the Mott and Bailey strategy, as the researchers call it, comes into play. The Mott is the safe descriptive finding, where they might say, PsyCap is associated with performance. The Bailey is the exciting, causally toned recommendation, like therefore implement PsyCap training to boost performance. They can retreat to the Mott if challenged, saying, well, we only said it was associated. But the implication of the Bailey is very strong, and in over half the studies, the causal implication of the recommendations was actually stronger than the causal implication of the sentences, actually reporting the results. And get this, there was no real link between how causal the language was in describing the results and how causal the recommendations were. This means sometimes the recommendations jumped much further in their causal claims than the actual findings could support. It is like saying the sky is blue and then recommending you build a rocket ship to travel to the blue destination. So, what does this all mean? It means that in research on psychological capital, just like in health research, scientists are using language that strongly suggests cause and effect and making recommendations that rely on these causal assumptions, even when their studies might not be designed to prove it. And sometimes they're even warning readers not to infer causality, while simultaneously doing exactly that in their advice sections. The researchers called this Schrödinger's inference, the caution and the causal claim existing at the same time, impossible to fully reconcile. This is a pretty big deal. If companies and organizations take the advice from these papers at face value, they might invest in training or strategies assuming they will cause specific positive outcomes, when the evidence might only show an association. This can lead to wasted time, money, and effort, and potentially even have negative consequences if the interventions aren't effective or are based on faulty assumptions. It also risks undermining the credibility of the research itself. The researchers are calling for more transparency. If the goal is to establish causality, scientists should be upfront about it. Use study designs that can actually support causal claims, like experiments, when possible, and be very clear about their assumptions, if it is an observational study. They should stick to less causal language and be explicit about what their findings can and cannot show. They also want people who use research, like HR managers or business leaders, to be more critical. When you see recommendations, ask yourself, does the study actually prove that this will cause what they say it will? Or is it just a suggestion based on an association? Now, no study is perfect. This study looked at 50 papers, which, while thorough for their methods, isn't the entire universe of PsyCap research. So, the findings might not apply to every single paper out there. Also, judging the causal implication of language can be a bit subjective, even with their careful rating system. For future research, it would be great to see if this pattern holds true in other areas of IO psychology, not just PsyCap. And it would be really useful to look at the actual quality of the causal models these researchers are using, if they are using any, to see if they're being applied in a way that truly supports causal inference. Scroll conclusion, this study demonstrates that the issue of unarticulated causal inference extends to PsyCap research. Conclusion, so to wrap up, this study is a crucial reminder that the way we talk about science matters a lot, especially when we want that science to be applied in the real world. The language of research can subtly influence our understanding and lead to recommendations that might be based on shaky ground. It is a call for greater clarity, honesty, and critical thinking from both the creators and the consumers of scientific knowledge. It pushes us to demand more transparency about what a study really shows, so we can make better, more informed decisions. What do you all think about this? Have you ever read a study that felt like it was leading you to a conclusion that the data didn't quite support? Let me know in the comments below, and if you found this video helpful, please give it a thumbs up, subscribe to RUBIN'S MindLab for more science breakdowns, and hit that notification bell so you don't miss our next video. Thanks for watching, and keep questioning everything.